Here's another try at solving a system of two equations and two unknowns. This one just requires a little bit of housekeeping and prep work ahead of time. When we are going to apply the elimination process to take the two equations and combine them through addition in a way that one of the variables disappears upon the addition, we need to have them in the same format so that the variables line up as we're looking at them. There's no magic format, but sort of the standard structure to see our equations when we're doing this looks like that. So ax plus by equals c. So we kind of want the x's and y's on the left-hand side and the constant on the right. The second equation is already in that format, but the top equation is not. And so what we need to do is rearrange the top equation so that it is in the same format as the second and everything's nicely aligned. So what we're going to do is take that first equation and add 2x to both sides. That's going to move the negative 2x on the right over to the left. So the new version of these two equations, that is wrong, will be 2x plus y equals negative 1. That's the top equation with 2x added to both sides. And then x plus 2y equals 4 is the second equation unchanged. Now what we want to do is add these in a way that eliminates one of the variables. Now if we add them the way they are, we'll get 3x's, 3y's, and a negative 3. And so nothing will be gone. But remember, we are in charge of these equations, and we are allowed to multiply either one of them by a constant, as long as we multiply both sides. And so we have to be a little bit clever. So for example, we could take this top equation and multiply it on both sides by negative 2. That would make this term a negative 2y, and then addition with that would wipe out the y's. Or we could multiply the second equation by negative 2 so that the x's are ready to be eliminated. And I'll go ahead and do that. So 2x plus y equals negative 1 is the first equation again. The second equation, I'm multiplying both sides by negative 2. So a negative 2x, a negative 4y, and a negative 8. Remember, that's from multiplying that second equation by a negative 2. And now we're ready to add these equations, because remember, the solution values we're looking for stay intact no matter whether we've multiplied an equation on both sides by a constant or whether we've combined these equations through addition. The mystery values of x and y are still hiding inside there. So when we add these two, 2x plus negative 2x gives me 0x. Y plus negative 4y is negative 3y, and negative 1 plus negative 8 is negative 9. And so now it's pretty obvious to see that the y value we're after is 3. And then we can take this value back to any of the equations in any of their forms and ask the equation to produce the corresponding x value. And let's go borrow this version. That's the easiest one to get hold of an x straight away and say, hey, equation, what x value do you have when y is equal to 3? So we plug in y equals 3 and then find out through some simplification that x is negative 2. And so the solution pair that we found are the x and y values negative 2 and 3. And we should check those every time. Don't always do it in the examples, but it's good practice. So when x is negative 2, let's take that back up to the top. Negative 2 times negative 2 is positive 4, and then minus 1 is 3. And ta-da, x equals negative 2 leads to y equals 3, and we should double check that in the second equation as well. I will leave that to you.